Hi. Um, Sorry, I will start with in English, so I will make it very basic to make it understandable. So, hello everyone. My name is Harun. I'm in the final stage of my PhD in the University of the Basque Country. And also I'm working consecutively in the CIC Nanagune about the lung cancer detection with utilizing with chemometrics. And also with the machine learning, which is the chemometrics is the subfield of the machine learning, as we know. So the topic is very interesting, very charming, very cool. So please stay tight, and I'm gonna make it very cool and make it very nice. So sadly, because the number of deaths worldwide is higher in the cardiovascular disease. But not far behind, cancer comes, which is affecting almost 10 million people worldwide. This number decreases to 2 million people in Europe, and also in Spain, it's around 125,000 of people suffering from the cancer. As we know that cancer comes in many forms, which is lung cancer is at the top, and almost 2 million people has been affected by the lung cancer. So that's why we know that early diagnosis is very crucial. But sometimes we have the issue because it's not possible, because with the conventional methods it's very invasive and it's very expensive and also very time consuming. But what we do is that we are gonna work on that to change the situation. But how I started my career, I started with in chemistry department in my bachelor in Turkey, and then I did quite almost over a year in Erasmus program in Lithuania. Then after finishing my degree, I work as a chemistry teacher as a full-time, but also doing it as a part-time during studying my master. And then I continued in my master's degree in nanoscience because I wanted to see deeply to understand how these tiny molecules, even like invisible to the eye, can make big changes. Then I did very shortly a summer intern in CIC Nanagune, as we know in Donosti. Then I started my PhD in UPV, working on lung cancer detection, as I described before, with the same group in CIC Nanagune. And here, the story behind of my research. So we have this issue related to lung cancer because, as we know that it's very invasive, and we want to find a fast, possible, and efficient way. So we have a collaboration with the hospital here, and also Biodonostia, which is one of the research center in Miramon. Now it's called Biokuputska. They changed the name last year, as far as I know. So we have a collaboration with them, and then the nurses in the hospital, they takes the blood samples from the lung cancer patients and also from the healthy controls, because the blood contains a lot of biomarkers. Then we use it in our techniques in the laboratory to find which biomarkers is important to define the lung cancer. So we have different patients, and then in the laboratory we have a technique which is called spectroscopy, basically which is the interaction between lights and the matter. So when the lights contacts with the blood samples, the molecules inside the blood samples, it vibrates. So it creates a biochemical signature which is very specific to each different biomolecules. So the blood samples contain proteins, carbohydrates, DNA, RNA. It's huge. It's like a pool. It contains many biomarkers inside to identify lung cancer. After interaction with the light, as I told you, it vibrates and it creates a spectra. And those spectra is one data. But the problem is that we have huge data set, and we want to see, get some information from those data set, but it's very hard to see with eyes. So what we use is that chemometrics. My research includes data analysis and statistic part. Chemometrics means chemical information, the data, the chemical information from the chemical system. So is a subfield of machine learning. It's very crucial because we can use chemometrics in different fields. We can use it in food analysis, not only the health and medicine field, but also pharmaceutical industry and environmental research. For example, security. There was a research years ago, almost 7 or 8 years ago in UK, and they were trying to detect the drug traces in the banknotes, in the cash, in the money. So they found that almost 11% of the banknotes in the UK has been contaminated by the drugs. So this is one of the cool research related to chemometrics. Basically, this is what I'm doing, and I'm almost at the end of it. So, ojalá, I will finish very well. So I wanna finish my presentation to give some home messages, because last year I remember I was presenting a poster just in this corner, and a lot of students came to me and then asking for like, oh, that's very cool. So what did you study? Like from chemistry to the cancer research. And then I say, okay, so this is the connection that you can do it. So I wanted to tell you, so whichever subject that you choose in the university, you can always find a way that you are interested in to work on the field. Because science includes very multidisciplinary fields. Even though you study with physics or chemistry or engineering, you can find a way that you study in the fields that you are interested in. So, and also I remember like a teacher years ago, he told me, Harun, you don't have to love always the subject that you're interested in, but what is important is that you have to finish job as perfect as possible. So if you start one subject that your aim is to make it efficient, of course it's better to, if you love and if you like it, it's gonna be more efficient at the end. But the most important thing is to make it work. So this is my home message. So I want to thank you all for listening to me and coming to here. Thank you.